another video for class 5, continuing on with using coupler curves. A closely related topic is cognates. What are cognates? Well, for a particular coupler curve, it's a different mechanism that can do the same curve, right? So just because we looked up in an atlas and we found a particular mechanism that can follow a curve, doesn't mean that's the only mechanism that can create that curve. And it turns out that I don't think this is actually possible for every single mechanism in coupler, but there are, generally speaking, 3 possible manipulations of or configurations of a 4-bar mechanism with a pointer on it that can achieve this. And why would we want to do this? Well, it's all about the grounds, right? We find a ground right here at this OA and this OB. We might not have a suitable attachment point on the machine that we're trying to create, and we have a certain shape and orientation that shape is going to be in. We might need to connect it way up at the top in here. So that's our motivation, that maybe we have a particular shape we want to do, but the grounds that we find in the first mechanism that we come up with just aren't acceptable. So here is the routine, and I've made an animation out of it. There's also, Norton has some pretty good videos that he has made. He made this big, large thing, contraption, and he has his helpers help them take it apart. So it's worth kind of checking that video out. But what I did is I kind of animated this right here. So the procedure is to take the legs and detach them and make them come out straight, so that the link 2, 3, and 4 are in line with each other, right? And now we draw lines that go beyond that are right along the edges of the point of interest, right? Of this thing that's sticking out, of the pointer, right? And then we draw lines that are parallel to them, that are passing through the new points, right? These hold down points. And now those triangles that they form, this guy right here, this will be another coupler extension. The same point of interest, but now it'll look like over here. And the same thing true over here. Here is the new coupler with extension. And if we extend the lines further right here, here is now a new, I'll say this is a new rocker, and I think this is the new crank, but don't, it's either the crank or the rocker, the length of it. And then this is true, this is the new for over here. So here's the first cognate, here's the second cognate, and here's the third cognate. And this is all kind of on the principle of equal triangles. They're, what do they call that? The similar triangles. These are all similar triangles. So you want to take a look at them. You can see that this right here is proportional to this right here, which is proportional right here. So 3, 9, and 6 are all the same triangle. They're just different scales of them. And I don't know what I was saying as part of that right there, but I made these really pretty green, yellow, and red. What was my point there? I don't remember. So anyway, what I can do is I can pull these points right here, these points of the original one, I could pull them back, all right, and that's going to also, because these links, that's going to pull this down right here. So this shape right here, this A, B, C, right? This OA, OB, and OC is going to have the same proportions as that A1, B1, and P, right? So once again, we have a similar triangle. So we can do the calculation. We could use that idea to figure out where that new location is. So this point right here is something we need to find, and it's going to cause us a little bit of aggravation trying to find it. But once you have these right here, you could use this geometry and figure this out. And now when you pull these back, These legs just go to the original position, but whereas this guy right here gets pulled down simply because these links, they have to go somewhere. So where are you going to figure it out? Where you're going to use this proportions of these triangles to figure out that location of C right there. And I think, yeah, that's why I was putting those in there, right? I think they have the same area. Maybe that's it. Something along those lines. I can't remember. You can look in the book and find out why I put those in there. So I don't remember. But anyway, you can pull these things apart, and you can find that they create the same curve. Right now, I think as you can see right here, it's tough to get them to do a full rotation, but they do a portion of that thing. Of course, this was not a full Grashof a linkage to start with, but you can see that what the coupler curves look onto them. And so some of this, I think, is related to this the Hoeken thing right here, right? So if you did the cognates of the Chebyshev right here and pull it apart, and it's really hard to follow this one right here, so you'd have to go step by step right there. But what you can see now is you actually have within here, it's kind of hidden, maybe I show it in the next, you can see that there is the Hoeken right in there, right? And then there's backwards, here's the other, here's like going the other direction with the Hoeken, right? So maybe this is a good one to try to do a screen capture of. So maybe if I go here and I save as a picture, and class is starting in 20 minutes, so I need to wrap these up right here. But if I go to this temp and I just go Cheby, I can't remember how it is. It's like this Chebyshev, something like that, and Hoeken combined in there, and then come back into. Actually, I think I haven't finished this other thing up. Let me. Ooh, I think I screwed it up. Damn, I closed too many things. No, here it is. Oh no, I have it right here. Okay, so if I let me save that right there. Save as, hopefully, and we'll go back to our motion gen, and I import an image. It's gonna remember. Yeah, here's our Chebyshev and our Hoeken. Let's move this thing. There you go. It doesn't matter. It doesn't matter where these things land. Not for now. So, like, if I were to go to this guy and this guy, oops. Okay. So I'm on the finger here. Alright, so you can run. Wee. And I think can I make it another one at the same time? Let me see. Can I make another one? Let me go this one right here. Let me try here. No, it's not going to like it. No, it didn't like it. It only wants one mechanism at a time. What I can do on here is I can make it a separate point. No, what I need to do is I need to go this. I need to come up to there. No. All right, let me just clear it. Let me clear a lot of stuff there. Clear that. Make them start again. You can see here's the Hoeken. Right in there. Right as part of that. And then this is actually, I think you can make the French dude's name with this one as well. Whichever is the French dude. Who's the French dude? I don't know. What's his name? I think I can make one in here where I come up to here. Now I can go to. Will it let me do it? Let me see. I can't remember. Go to there. Come to here, and come to there. If I grab that one, I think it'll let me get an extra spot. All right, I'm gonna grab that. Make that one the input. Is that where it happens? No. This one, maybe. I don't know. Maybe trash that. No, I don't know. No, it's not going to work. What happens here? You can't do it. No, it's not a solvable one. All right, so I was just messing around. It's a good thing to explore this. You can change the colors of the thing and stuff. But anyway, my point of this thing was supposed to be that this is the Huekin related to the straight line right here, the Chevy Chev right there. That they are related to each other and they're cognates. Did I have anything else as part of this? I don't think so. Let me see. This was another demonstration for a different one of doing these cognates. Interesting. And this was one, I think we're trying to show you that we could make an equivalent 5-bar thing that goes on. And 5 bars quite often will have a gear involved, like one of the legs will be attached to a gear to try to constrain the degrees of freedom. And then this was another cognates example here that I put together. And try to demonstrate the different cognates making the same curve. Wow. That was pretty cool. There's a different one. Anyway, I assigned these to some of the 500 level class last year, and so I think that's what I'll do this year right here, is to try to get the 500 level class. Will be a little more difficult than the 400 level class. It'll be you'll soon be doing more MATLAB things along there, but this is kind of an interesting topic. I like it. I want to see it get used for something more. So here you go, cognates.